Assalamualaikum warahmatullahi taala wabarakatuh. I am TS Irma from Institute of Science UiTM Shah Alam. The title of my presentation today is Biosynthesis of Tin Oxide Nanoparticles by Aqueous Leaf Extract of Aquilaria malaccensis or agarwood. For the introduction, the application of tin oxide nanoparticle that has a large band energy, which is 3.6 eV, can be found in lithium-ion batteries, solar cells, catalysts, electrode, and gas sensors. The conventional method to synthesize tin oxide nanoparticle is by using salt gel method, hydrothermal, high-energy ball milling, and so on. However, this method gives disadvantages such as toxic and hazardous chemical, high temperatures and energy, and also it is expensive. So scientists need to find an alternative route to overcome this adverse effect. So here come the biosynthesis approach, which offer advantages such as simple, environmental friendly, and also economical. The process involves the utilization of the bioactive compound in the plant segments that act as the reducing and capping agent. It also helps the system to avoid the agglomeration between the particles. This is the example of several plants that were reported to be used in biosynthesis of tin oxide nanoparticles such as Rhizopus jujubi, Camellia sinensis, Lithia jubeba, and so on. Aquilaria malaccensis is commonly called agarwood and it can be found widely in Asia. Its leaf contain bioactive compound that required for this study. No previous report in the literature on biosynthesis of tin oxide nanoparticle using this plant. So, to benefit the remarkable properties of tin oxide nanoparticle and agarwood, we report for the first time the green biosynthesis of tin oxide nanoparticle using an extract of agarwood leaf, which is from the fresh and dry leaf as denoted as Fg and Og throughout this study. The methodology involves several steps. The aqueous solution of the leaf extract was added to the tin chloride pentahydrate, which is act as the salt precursor solution, and it was stirred for 3 hours. Later, it was brought to centrifugation process, whereby a gelatinous solution was separated. Then the gelatinous solution was dried up to remove the water content. Last step is the calcination process that carried out at 700 degrees C that gives tin oxide nanoparticle as the outcome. FTIR analysis evidence the functional group of the bioactive compound that required for this study. While FTIR spectra of tin oxide nanoparticle using fresh and dry leaf of agarwood evidence the functional group that pertinent to the construction of tin oxide nanoparticle. FESAM display the morphology of agglomerated spherical light, extremely crystalline nature, and uniformly distributed for both samples, while EDX patterns show the presence of intense peaks of tin and oxygen. XRD pattern of the biosynthesized tin oxide nanoparticle is agreeable with previous study. The peak at 2 theta values and planes indicate the formation of tin oxide with tetragonal structure. No peaks corresponding to other phases are detected. The crystallite size was found to be 6.3 and 3.4 nanometer for Fg and Og respectively. Og shows more pronounced and narrower peak as indication of improved crystallinity associated with better formation of tin oxide nanoparticle. It is believed this is attributed by the effective concentration of the extract from dry leaf of agarwood. From the literature, higher polyphenolic content was reported to be found in dry sample rather than fresh sample. So the reducing and capping action occurred more efficiently, and the stabilization of the nanoparticle is also believed to take place, which later lead to the formation of smaller crystallite size of OG sample. UV with diffuse reflectance show OG has higher reflectance than FG due to smaller crystallite size and larger surface area. According to band gap plotting, the band gap of FG sample and OG were found to be 3.23 and 3.35 eV respectively. The value of band gap for both samples recommend that the biosynthesized tin oxide nanoparticle is useful for photocatalytic applications. So for the conclusion, we report for the first time the biosynthesis of tin oxide nanoparticle using leaf extract of Aquilaria malaccensis or agarwood. Polyphenolic type compound from agarwood leaf is believed act as reducing and capping agent. FTIR analysis confirmed the presence of pertinent functional groups. XRD shows the tetragonal structure of tin oxide nanoparticle. FESAM result display morphology of tin oxide nanoparticle with a uniform distribution of agglomerated spherical nanoparticle. And lastly, DRS result gave band gap value that suggests the significant potential in catalysis and optoelectronic devices. We would like to acknowledge Institute of Science for the provided facility and Eaglewood Ventures and Durham Berhad for agarwood leaf samples. This is the list of references that I used throughout this study. And thank you so much for listening.